The launch of the James Webb Space Telescope on Christmas Day 2021 has been quite successful. This extraordinary has revealed the universe in surprising ways. Recently, 6 galaxies were found that existed just 500 million years after the Big Bang. Most impressive is that these galaxies are well developed and contain more stars than current galaxies, including our own Milky Way. This discovery challenges our model of cosmology and leaves scientists baffled. Researchers at the University of Minnesota have found one of these galaxies so peculiar that it may be necessary to rethink everything from the beginning. Welcome to CZ Science. It's time to explore the James Webb Space Telescope, which is capable of collecting about 10 times more light than the Hubble Space Telescope and is much more sensitive to longer wavelengths and signals in the infrared spectrum. This gives scientists access to a new window of data about the early universe. However, to understand the beginning of the universe, we need to go back in time to a point when time and space did not exist. According to the theory of cosmic inheritance, the universe was born with the Big Bang as an extremely hot and unthinkable point. When the universe was just 1/100th of a billionth of a trillionth of a trillionth of a second old, an incredible expansion known as the invisible occurred, in which space itself expanded faster than the speed of light. During that time, the universe increased in size at least 90 times, going from a subatomic size to the size of a golf ball in an almost instantaneous instant. After this event, the expansion of the universe continues, but at a slower pace as space expands. The universe was cooling and matter began to form approximately 1 second after the Big Bang. At this stage, the universe was composed primarily of neutrons, protons, electrons, electron antiparticles, photons, and neutrinos. However, for the first 380,000 years or so, the universe was so hot that light couldn't shine. It was only after 380,000 years that matter began to succeed enough to allow atoms to form. From that moment on, the universe entered a phase of darkness, as there were still no stars or other bright objects formed. Fast forward to about 400 million years after the Big Bang, and we can witness the universe emerging from its dark age. This phase, known as the reionization period, lasted more than 500 million years, during which time the first stars began to form. So, according to scientists, galaxies began to form in the first billion years after the Big Bang and went through adolescence in 1 to 2 billion years. However, the James Webb Space Telescope found not just 1, but 6 fully formed galaxies just 500 million years after the Big Bang. This presents a problem. Using unique observations from the James Webb Space Telescope, a team led by the University of Minnesota peered back over 13 billion years to discover a tiny, singular galaxy that is spawning new stars at an extremely high rate for its size. This galaxy is one of the smallest ever found at this distance and could help astronomers gain more information about galaxies that existed shortly after the universe began. Although the volume of this galaxy is approximately 1/1,000,000th that of the Milky Way, you can see that it is still forming the same amount of stars each year. According to the scientists, the galaxies that existed during the universe's infancy are quite different from those we currently observe in the nearby universe. Studying these galaxies could provide insights into the origin of the first stars and galaxies in the universe's dark age, an as yet unsolved mystery of how the universe came to be. As the days go by, new discoveries from JWST observations reveal that the universe, especially in its early stages, was even more amazing than we ever imagined. Not only did Webb find these ancient galaxies, it also identified a black hole almost as old as the universe itself. Scientists have discovered what they believe is the oldest known black hole, thanks to the telescope's powerful sensors that captured this elusive entity. This supermassive black hole, with a mass 10 million times that of our Sun, existed at the center of a galaxy. This event occurred about 570 million years after the beginning of the universe, a time so far away that it is difficult to comprehend. To give you an idea, it is estimated that the universe itself has an age of 13.7 billion years. Observations made by the James Webb Space Telescope have revealed the presence of an active supermassive black hole with a mass 10 million times that of the Sun, which is growing rapidly by absorbing matter from the space around it. This is the oldest growing supermassive black hole ever detected, occurring just 570 million years after the Big Bang. However, scientists hope that he will not hold this record for long. This black hole was found inside one of the oldest galaxies ever detected, formerly known as EGSY8 but now given the name SN19. This discovery could contribute to solving one of the biggest enigmas of the early universe, how the black holes in the cosmic dawn managed to reach such an immense size in a short period of time. We have discovered the most distant active galactic nucleus and the most remote black hole ever found, said an astrophysicist involved in the discovery. Initially, scientists were studying SN19 as part of their research into light generated by star formation in the early universe. This light, known as Lyman alpha emission, is produced by the ionization of neutral hydrogen due to star-forming activity. In the beginning, the universe was shrouded in a haze of neutral hydrogen that blocked the propagation of light. Only after the ionization of this hydrogen could the light spread freely. This period of reionization, as it is called, is still not completely understood. We know it occurred in the first billion years after the Big Bang, which occurred 13.8 billion years ago, but looking so deep into the early universe is extremely challenging. SN19 and other extremely old galaxies are ideal targets for this survey because of their relative luminosity. This galaxy was identified in Hubble Space Telescope data in 2015, and at that time was thought to be the oldest and most distant galaxy ever observed. Subsequent observations confirmed its existence, but more detailed information remained elusive. The oldest light in the universe has shifted so far into the infrared region of the spectrum due to the universe's expansion that a dedicated and powerful infrared instrument like the JWST is needed to investigate it. When JWST went into action, SN19, the brightest of the Hubble galaxies at that time, became an obvious target. The telescope observed the galaxy for just an hour using all 4 of its instruments, but it returned an impressive amount of data. At the time, I was like, wow, look at everything we can observe with the JWST. We've seen this whole part of the spectrum of this galaxy and other galaxies from the early universe that we've never seen before, said astrophysicist Rebecca Lawson. I was simply overwhelmed by the amount of information. However, soon she noticed something unexpected. In addition to the light coming from star formation, there was a broad emission feature usually associated with active galactic nuclei, AGN. When she mentioned this to some AGN researchers, things started to get interesting. Typically, a galaxy in the early universe emits light from an AGN, active galactic nucleus, or star formation. Observing both in the same galaxy was extremely surprising. There is some effect the black hole is having on the emission lines we are observing, but most of the light we see in our images is still dominated by the contribution of star formation from the galaxy. It's not that unusual that a supermassive black hole has existed for over 13.2 billion years and is growing. Even bigger black holes have been detected in the early universe. Scientists still don't know how these black holes in galaxies managed to reach such massive mass so early in the history of the universe. Now, with the discovery of this black hole only about 500 million years after the universe's emergence, we have a mystery on our hands. The picture of the early universe is changing faster than expected, and whether we like it or not, it's time to go back to the drawing board. What do you think? Leave your comments to let us know, and don't forget to subscribe to CZ Sciences. Together we will continue to explore.